Okay, good evening everyone. Today we are starting with the topic of determinants and we'll also discuss what are cofactors and minors of a determinant. Okay, so we'll start with what is a determinant first. For every square matrix, when we have a matrix which is square in nature, which means it must have equal number of rows and columns. So for every square matrix, let's say of order n, it can be given an individual value, a value associated with a matrix. So when a value can be associated with a certain matrix, that value is called a determinant. It's called a determinant. So suppose we have a matrix, square matrix of order 2, which says A equal to A, B, C followed by D. So first row contains A and B and second row contains C and D. So the determinant of the matrix A will be A multiplied by D negative B multiplied by C. So it is the left diagonal minus the right diagonal. We need to keep in mind that only square matrices can have determinants. In case we have a rectangular matrix, the determinant cannot be calculated. Please keep that in mind. Any questions from anyone? Okay. Now we'll move on to the next topic. Suppose we have a determinant which has an order of 3, which means it has 3 rows and 3 columns. Each element of the determinant is shown on the screen. The first element, I mean to say the element in the first row, first column is represented by small a 1, 1. Similarly, the element right to it is represented by small a 1, 2. The last element in the first row is represented by a 1, 3. Similarly, the element in the second row is represented by a22, a21, a22 and a23. The third row is represented by a31, a32 and a33. This is how the determinant is framed. So, when we expand the determinant by the first row or the first column, in this case we are expanding it by the first column, so the answer to the determinant would be a11 times the cofactor of the first element. Now how to calculate the cofactor of the first element? We need to hide the first row and the first column, and whatever is visible we put it inside a determinant. So let's say for this example, if a11 is the first element, we hide that row, we hide that column. Now the elements that are visible, which is a22, a23, a32, a33, must be put inside a new determinant. Okay. Similarly, we can calculate a21, the cofactor of a21 and cofactor of a31 as well. Let us go into a little bit of details on this. Let us take another example where we study this in details. So suppose there is a determinant and we want to calculate the minor of the determinant. So let's look at the screen. The element that we are discussing, or the matrix that we are discussing, is a11, a12, a13. It's pretty much similar to the one that we were doing just before this. So in order to calculate the minor of a11, what we do is we hide the first row and the first column. What is visible on hiding the first row and first column is a22, a23, a32 and a33. That in a determinant is called the minor. Similarly, if I want to calculate the minor of A12, then we need to hide the first row and the second column. The visible elements will be A21, A23, A31, A33. Okay. In case we want to calculate minor of 13, A13, on hiding the first row and the third column, we'll get A21, A22, A31, A33. Any questions from anyone? Okay. In order to calculate the value, the numeric value of the determinant, what we do is we write determinant. It is represented by a small triangle. We call it the det. It is equal to the first element multiplied by its minor, negative second element multiplied by its minor, positive third element multiplied by its minor. We can perform the same operation for the second row or the third row. Okay. Let us take a numeric example to understand this concept. Now, there is a determinant which is 104 in the first row, 3, 5, negative 1 in the second row, and 0, 1, 2 in the third row. Now, for this determinant, we intend to find the minor of the first element. The minor of the first element. See, as on the screen, we'll hide the first row and we'll hide the first column. What's visible after that is 5, negative 1, 1 and 2. That goes inside a determinant. If you remember what we discussed in the first slide, that the numeric value of this determinant will be 5 times 2, negative 1 times negative 1. And our answer comes out to be 11. So what is the value of the minor A11? The value of A11 is 1. So the minor of A11 will be 11. Similarly, the minor of A12 means the first row, second column. So when we hide the first row and the second column, we get 3, negative 1, 0 and 2. When we simplify that, we get 6, negative 0, which gives us 6. So what is the minor of the second element, A12? The minor of the second element is 6. Similarly, when we calculate the minor of A13, we need to hide the first row and the third column. What is visible is 3, 5, 0, 1. On simplifying, we get 3 subtracted 0. So my answer is 3. This is how we calculate the minor of A13. When we want to calculate the minor of A21, means the second row, first column. The minor of A21 will be, on hiding the first row and the second column, we get 0, 4, 1, 2. So the value will be 0, negative 4. That is minus 4. In similar way, we need to calculate each and every one of the minors. Let's have a look at the other minors. Suppose we take the minor of A31, the third row, first column. So we need to hide the first column and the third row. What will be visible is 0, 4, 5, negative 1. On simplifying, we get 0, negative 20. So that comes out to be negative 20. So the value of the minor of third row, first column is negative 20. Similarly, we can calculate each and every one of the minors. Now, how to calculate the cofactor? The question says calculate the minor as well as the cofactor. In order to calculate the cofactor, it's a very simple exercise that we need to follow. The steps are, we first need to calculate the minor, which is clear to everyone, I hope. So step 1 is to create or find the value of the minor. Then In order to calculate the cofactor, let's say we need to calculate the cofactor of A11. So the cofactor of A11 would be -1 to the power number of rows plus number of columns. So in this case, number of rows is equal to 1, number of columns is equal to 1. So -1 to the power of 1 plus 1, which is 2. Now the value of -1 to the power 2 is of course equal to plus 1. We need to multiply plus 1 to the minor. If you remember, the value of minor was 11. So the cofactor would be 1 times 11, and that is 11. Let's take another one. The cofactor of A12 would be -1 to the power 1 plus 2, which comes out to be -1, times the minor of this element. The minor of this element is 6. So my answer comes out to be -1 times 6. So that is -6. Similarly, we can calculate all the other cofactors for this given determinant. Let us take another random example of the cofactor of second row, third column. Let us quickly have a look at the determinant first. Second row, third column, it comes out to be this one. The minor would be equal to 1. So the cofactor would be -1 to the power 2 plus 3, which is -1, times the value of the minor, which is 1. So -1 times 1 is equal to -1. This is how we calculate the cofactor of a element present in a determinant. Does anybody have any questions, any queries? Okay. So today we recapped the concept of minors of a determinant, and we did the concept of determinants, the cofactors of a determinant. So we studied minors and cofactors for a determinant. In the next session, we'll be carrying forward from the next topic. Thank you everyone. Good day.